Hi, everybody. I would like again to greet you and also wish you good luck and success in your study. Today, we are going to continue again our topic on quadratic equations. Quadratic equations have got many ways of solutions. We mentioned in our previous videos that there are several types of quadratic equations, especially if you remember last time we spoke about the incomplete quadratic equations. When B or C can be zero, so in this case, the equation becomes incomplete. And so we mentioned that we can solve in this case, we can apply easily the factorization method. Today, we are going to continue to a new video where we are going to explain this time the complete case. So first of all, what's the complete case? Let's explain. Actually, ax squared plus bx plus c equals to 0. This is the equation, quadratic equation. We said that always there is going to be, in all cases, there is going to be a is not 0. So in this case, if a is not 0, we said that there can be b equals to 0 or c equals to 0. Sometimes they can be, both of them can be 0. So sometimes we can have such equations, and it's also incomplete equation. And in this case, 3x squared equals to 0. Actually, x squared equals to 0, x equals to 0. So we know that there are two equal rules. x1 equals to x2 equals to 0. This is the case when we have two equal rules. So, however, it's also incomplete case. And if we have b equals to 0, we get such an equation. For example, 2x squared minus 8 equals to 0. We said that we can do like this factorization, 2 times x minus 2 times x squared minus 4 equals to 0, which means that it is 2 times x minus 2 times x plus 2 equals to 0. So from here we get, according to null factor theorem, x minus 2 equals to 0 and x plus 2 equals to 0. So obviously we have here x equals to 2, x equals to negative 2. As a matter of fact, we also mentioned such incomplete equations. You might notice that, for example, 2x squared minus 20 equals to 0. In this case, b is 0. Here we have b is 0. This is also b0 case. And we said that in this case, we cannot find the root of 10. We can solve it. It's kind of 2 times x minus under root 10 times x plus under root 10. This is also the continuation of factorization topic. Also, last time we mentioned such an equation, 2x squared plus 6x equals to 0. Here c is equal, this is the c equals to 0 case. So when we multiply 2x, we get 2x times x plus 3 equals to 0. Obviously, here x equals to 0 and x equals to negative 6. So for incomplete case, actually we considered here all all cases here, we considered here all possible incomplete equations. Now let's continue with today with complete case. Complete case guarantees that we have complete equations. Of course, we are talking here about the quadratic equations. So with complete equations, we have all the coefficients present in the equation. For example, this is the complete equation, x squared plus 3x plus 2 equals to 0, or 3x squared minus 2x plus 3 equals to 0. Today, we are going to learn a special case of complete equations, which we have here coefficient 1. So let's continue. Let's see several examples and try to try to solve these equations on this example. So first of all, let's take x squared plus 3x plus 2 equals to 0. This is the complete equation, complete quadratic equation. You see here also we have 1, we don't write it. Yeah, it's not seen, but it exists there. So a is equal to 1 here. So b is equals to 3 here, and c equals to 2. You don't need to always write these coefficients. For the first case, I am writing this because I want you to be clear what you're going to do. So actually, we are going to solve such equations also with factorization method. How we can solve it, guys? So look, we have such an equation, x squared plus 3x plus 2. What I recommend here, in order to expand the factorize it, we need to look at these two. So this is the very important part of our equation. So 2, and to write the divisors of 2. So 2 can be 1 and 2. So 1 times 2 makes 2, or minus 1 times minus 2 makes 2. However, we have to be sure that their sum should give us these 3. Yeah. So in this case, we see that the corresponding values here, corresponding factorization parameters can be 1 and 2. So in this case, what happens? This 3, we are going to expand in 2 ways. So we are going to write x plus 2x. So these 3 we divide into 2 parts. So x represents 1, 2x represents 2. So actually what we get, x squared plus x plus 2x plus 2 equals to 0. Now we can group here. It's called grouping symbols. So x we can factor out here, x plus 1 plus 2 again we can factor out here. We are going to get x plus 1. So as a continuation, we are going to write, you can see here x plus 1 also the common factor. So x plus 1 times x plus 2 equals to 0. So we can solve this a factorized form. It's going to be x plus 1 equals to 0 and x plus 2 equals to 0. From here we get x equals to negative 1 and x equals to negative 2. So our solutions are negative 1 and negative 2. Again, what happened here? We looked at 2 and tried to get out the numbers, which product will give us 2. And when we sum, we get 3x. So it's going to be x plus 2x. And then, you see the process. Now let's do another one here. In this example, we are going to also continue, example 2. We are going to also continue to extend this idea. Minus a squared minus 5a plus 6 equals to 0. Again, we said that we are looking at 6. Let's write all combinations of product to 6. So 1, 3, 1, 6, yeah. We can write 2, 3. We can write minus 1, minus 6, minus 2, minus 3. However, we have to be sure that the sum should be here minus 5a. So if it is minus 5a, then well-suited numbers here are these ones, yes? Minus 2 and minus 3. So we are going to put here minus 2, minus 3. Let's check. So it's going to be a squared minus 2a minus 3a. So 5a we have divided into sum of two expressions. 6 equals to 0. Try to not to mix it with the solutions. They are not solutions here. Minus 2 and minus 3, they are not solutions. We are looking for solutions, but they are not still solutions. We use them to write 5 in the sum as the sum of minus 2 and minus 3. So what we do here, we group again symbols. So from these two, we factor out a. It's going to be a times a minus 2 minus 3 times again a minus 2 equals to 0. You can see a minus 2 is the common factor again. So a minus 2 times a minus 3. It's equals to 0. In the meantime, you have to notice that there is minus 3. So this is something that you should never forget. If you factor out minus 3 here, it gets a minus 2. I hope that everybody understand if you factor out minus 3 here, you're going to get a minus 2 here, not plus minus 2. So a minus 2 is the common factor. We factored out because of this. So again, null factor theorem. A minus 2 is equals to 0. A minus 3 equals to 0. So from here we get roots a equals to 2, a equals to 3. You see, this is our roots. These are our roots. So our roots are 2 and 3. I hope that this is clear to everybody. I want to continue with another one, and the last one probably. Let's see such an equation, number 3. X squared plus x minus 20 equals to 0. Let's try to do such an equation here. Again, we have to look at this number, minus 20. So which numbers give us minus 20? So 1 minus 20. If we multiply 1 by minus 20, we get minus 20. So 2 minus 10. Or we can get here 4 minus 5. Or minus 5, 4. Also, we can have here minus 1, 20. And minus 2, 10. So for all of these products, give us the product minus 20. So for each these numbers, we get minus 20. However, again, we have to be ensured that we are going to get plus x. Plus x is here plus 1x. So we have to get 1 here when we add them. To get 1 here, we are going to get, for example, the combination we didn't write here, the combination minus 4, 5. Sorry, minus 4, 5. Let's try to write it like this. X squared minus 4x plus 5x minus 20 equals to 0. You can see this minus 4x plus 5x will give us x. So everything is correct here. So what happens next? From these two, we factor out x. It becomes x times x minus 4. And from these two, we factor out 5, positive 5. We get x minus 4. It's equals to 0. So again, x minus 4 is actually the common denominator, the common factor here. So we can factor it x plus 5 equals to 0. So x minus 4 equals to 0. X plus 5 equals to 0. Actually, x equals to 4 and x equals to negative 5. This is the answer. So we got 4, negative 5. These are our roots of the solution of these equations. Well, in this video, we again looked through the case when the coefficient of x squared is 1. And also, we mentioned how to factorize such expressions. This video will be, I hope, will be useful for you. In general maths, it's used in, you can see from the topic, it's used in nearly all exams, in IGCSE, in SAT, in MYP program, International Baccalaureate, and in all other programs. I think that it will be also English programs. It will be also for you useful. So do not forget to subscribe to the videos, to our YouTube channel, and to get new videos, and to share this with friends. And also do not forget to make comments to the video. We will read them and also try to take into consideration our next videos. So see you guys in our next videos. We are going to continue this topic in the future videos. See you. Bye. Take care.